Ever think about starting your own business? A lot of teenagers do. And if it sounds interesting, you may want to go to this website. The Small Business Administration of the U.S. government has a couple of pages dedicated to things that you need to think about if you, a teenager, want to start a micro business. Teenagers can do a lot of things and make some money. They could have a business that did auto detailing, or a delivery service, or telemarketing. And you know what? The computer and the internet make it possible for you to penetrate markets and expose your business to a whole lot of people, and for very little money, start a really successful business. Well, what's math have to do with starting a business? Quite a bit. Let's say you're thinking about starting an auto detailing business. You do a little bit of research, and the first thing you discover is that you're going to need some tools. You're going to have to spend about $400 on the tools necessary to operate this business. Then you discover that you're going to spend about $10 per detailing job on supplies. But you also discover that people will be able to pay you $30 for each car that you detail. Well, that's interesting, but I wonder when you'll start making money. I mean, you got to pay back that $400. I wonder when you'll start actually making a profit. Could we figure that out with math? Yeah, I bet we could. We could say that our costs were $400, the amount of money we're spending on tools, plus $10, the amount of money we're spending on supplies for each job, $10 times the number of detailing jobs we do. And we could say our revenue, or the amount of money that we took in, was $30 times each detailing job we did. We're calling X each detailing job. If you did 4 detailing jobs, X would equal 4. Now, at the point where our revenue equals our cost, we've paid back the $400 that we initially spent for tools. If we set cost equal to revenue, then we can figure out how many jobs it will take before we pay back the $400. I substitute 400 plus 10x for C and 30x for R, and I've got an equation: 400 plus 10x equals 30x. All right, so my equation for when my costs will equal my revenue, or when I will pay back all that $400 with profits from my detailing business, is 400 plus 10x equals 30x. That means 400, the initial investment in tools, plus $10 times the number of detailing jobs we're doing, equals $30 times the number of detailing jobs we're doing. And if I could solve that equation for X, then I'd know the number of detailing jobs that I had to do in order to pay back the entire $400 out of the profits of the detailing. And one way I could solve this equation is with a table. Now I've got 2 equations. One spells out what my total cost would be, and the other spells out what my total revenue would be. And if I put these in a table, I could figure out at what point, after how many detailing jobs, have I paid back the entire investment in tools for the business. So the first thing I do is fill out that X row. And I put in 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And that's the number of detailing jobs that we've done. Now, I've got to calculate for each of those X values a total cost value. a total cost figure. And I'll use this equation. My total cost equals $400 plus $10 times the number of detailing jobs I'm going to do. So I'll substitute 2 for X, and I come up with those figures. Now I got to fill in that revenue column or that revenue row. And again, I'll substitute the X value into the equation and come up with a total revenue figure. So if I did 2 jobs, my revenue would be 2 times 30 or 60. Now, I've got the table filled out. Can I tell how many jobs it's going to take before I've paid off that $400 worth of initial investment in tools? Well, yeah, where C equals R, that's where I've paid off that initial investment. And I can see that after 20 jobs, my costs are $600, my revenue is $600. Everything's profit after that. I could also solve this equation for X using a graph. I've got 2 equations really. I've got a cost equation and a revenue equation. But since my graph's got an x-axis and a y-axis, I'm going to rewrite those a little bit. I'm going to say that my cost, or my y, equals 400 plus 10x. And I'm going to say that my revenue, or my other y, equals 30x. Now I could graph those equations onto this graph table on the left. And I could do that a number of different ways, but one way I could do it is with the table that we created on the last slide. I could get the x values and the corresponding y values and then plot both of these equations. And the cost equation would look like that, and the revenue equation would look like that. And where those 2 equations cross is where my cost equals my revenue. And that ends up being when X equals 20. I could also solve this equation using algebra. I just manipulate the equation until the X was the only thing left on the left side of the equation, and whatever was on the right side of the equation is what X equals. It's my solution to this equation. So, first thing I want to do is get all of my X's on one side of the equation. So I'm going to subtract 10x from both sides of the equation. When I do that, I end up with 400 equals 20x. Now I got to get rid of that 20 times x. So I'm going to do the opposite of multiplying by 20. I'm going to divide both sides of the equation by 20. And that simplifies to x equals 20. So now we've solved this equation 3 ways. We solved it using a table, we solved it using a graph, and we solved it using algebra. And thank goodness we got the same answer each time. Well, we've been talking about equations, and I think you know what an equation is. An equation is just a mathematical statement that says that 2 things are equal. It says that the expression on the left equals the expression on the right. And any mathematical statement with an equal sign in it is an equation. But there are different types of equations. For instance, there's a function. And a function is an equation that's been manipulated so that only y is on the left side of the equation, and it says y equals something. So this is an equation, but it's also a function. This isn't a function, although it is an equation. It's not a function because it doesn't say y equals something. It says y minus 2x equals something. Now I could graph a function, and this function y equals 2x plus 1 would look like this. Now the first thing you want to notice is that this graphs as a straight line. And for that reason, we call it a linear function. If the graph of a function is a straight line, it's a linear function. Now, if x were squared, or to the third power, or to the fourth power, it wouldn't be a linear function. It'd have curves in it. But if x is to the first power, you're going to get a constant rate of change, a straight line graph, and it's a linear function. There's something else that's real interesting about this function. It's in slope-intercept form. What is slope-intercept form? Well, it's a function that could be written in this form. Y equals mx plus b. And that m is the slope of the line that would be the graph of the function. And the b is the y-intercept. That's where the line crosses the y-axis. It's where it intercepts the y-axis. Now in this equation, y equals 2x plus 1, 2 is my m, and that's the slope of the line. And you remember what slope means. It's rise over run. So if I take any point on that line, I can take a rise of 2, 1, 2, and a run of 1, 1, and get another point on that line. And I could do that again, 1, 2, and 1. And that b is 1. 1 is the y-intercept. That's where this line crosses the y-axis. Now if we were to take this backwards, and you were given this equation and asked to graph it, you'd start with that 1. You'd say, I got a point, that's one of my points, where the number 1 on the y-axis is one of my points. And then you'd say, my slope is 2. So from that point, I'm going to rise 2 and run 1, and I put another point right there. And you only need 2 points, but let's say you wanted a third one. You go from that point, rise 2, run 1, and you'd have another point right there. And then you could just draw a line between those points, and you'd have graphed that function. This You Try a Problem asks you to do quite a few things. You're supposed to solve this equation, 2x plus 6 equals 4x minus 2, and you're supposed to solve it 3 ways: using a table, with a graph, and with algebra. You definitely want to hit your pause button, try the problem, and then after you've finished all 3 solutions, hit your forward key to move on to the answer. Well, let's solve this equation first using a table. I'd need a column for x. I'd need a column for the left side of the equation, 2x plus 6. And I'd need a third column for the right side of the equation, 4x minus 2. Now, x is my input value. I'm going to input values for x. And then I'm going to calculate my second column based on this equation, 2x plus 6, and come up with values that correspond to each of those x's. Then I'm going to do the same thing for 4x minus 2 and come up with the corresponding values there. Then I'm going to find out at what value of x does this equal this. And I can see right there, when x equals 4, both of the expressions totals 14. So my solution is x equals 4. Now I could also do this with a graph. I have two equations, y equals 2x plus 6 and y equals 4x minus 2. And I could graph those and it would look just like this. My first equation is y equals 2x plus 6. Well, you remember that plus 6 is my y-intercept. That's where this line crosses the x-axis. And that 2 is my slope. I'm going to rise 2 and run 1 to get my next point. And then I'll rise 2 and run 1 to get my next point. So that green line represents y equals 2x plus 6. My second equation is y equals 4x minus 2. My y-intercept is minus 2. So I cross the y-axis below the x-axis at a negative 2 number. And then my slope is 4. That means I rise 4, 1, 2, 3, 4, and run 1. 1, 2, 3, 4, run 1. So that blue line represents y equals 4x minus 2. Where do those two lines cross? Right there at a value of 4. We could also solve this equation algebraically. I'd set 2x plus 6 equal to 4x minus 2. Now I got to put all my x's on one side of the equation and all my straight numbers on the other side of the equation. And that simplifies to 8 equals 2x. And then I divide both sides of the equation by 2, and I come up with x equals 4. I bet this one made you think a little bit. It says find x and then find the perimeter of this square. Well, they tell us it's a square. And in a square, each side's equal in length. So I know that 3x minus 6 equals 2x minus 2. And I can set that up and solve for x. I can say 2x minus 2 equals 3x minus 6. And then I manipulate it algebraically, and I come up with my solution. X equals 4. Well, now I know that each side of this square is 4 units long. And there's 4 sides, and my perimeter is the sum of those 4 sides, or 4 times each side. So my perimeter is 4 times 4, or 16. You're going to need some graph paper to try this problem, so hit your pause button, either find a sheet of graph paper or make a sheet of graph paper on a blank sheet of paper, and then do the problem, graph this equation, hit your forward key, and see how I solve the problem. We're asked to graph the function y equals 2x plus 3. And if you do that correctly, it's going to look just like this. Now, how do we end up graphing this? Well, the first thing we've got to do is remember that plus 3 is our y-intercept. That means the line is going to cross the y-axis at 3. So we'd put a point right there at 3. Now the other thing we know is that the slope of this line is 2. What's slope mean? Well, it means that from any point on the line, we can rise 2 and run 1, and we'll hit another point on that line. So if we started up here at our y-intercept point, 3, and we rose 2 and ran 1, we could put another point right there. And if I've got 2 points, that point at the y-intercept and the point that's a rise of 2 and a run of 1 from the intercept point, then 2 points is all I need to draw a line. And I could draw the line that represents y equals 2x plus 3. That's our lesson on equations and functions. Now it's time to test your skills. Go to www.mastermath.info and download the worksheet and the worksheet answer sheet for equations and functions. After you've done the worksheet, go back to Master Math and try the quiz on equations and functions. Come back and see us again soon.